Hey guys, the sixth and final lesson of chapter 13 is called Apply the Law of Cosines. Now the law of cosines is different than the law of sines that we learned in the previous lesson. When we talk about law of cosines, obviously we're going to be using the cosine function. I'm not going to take a lot of time in this box to explain law of cosines. We're going to see it a little bit down below. But basically, whenever you have, three sides or two sides and an included angle, we can use the law of cosines. Again, we have to have the included angle. So for example, if I had this side and this angle right here, I can use the law of cosines. Now, as you learned from the previous lesson when we talked about law of sines, maybe you can have two sides and a non-included angle, all right? And then we talked about other examples and other cases in the previous lesson. But law of cosines works in its much easier way, I think, formula-wise, because you don't have to worry about quite so many cases. When we take the inverse cosine, we get an angle somewhere in the first quadrant and then the second quadrant. And so that takes care of either our acute or obtuse option, like we don't have to worry about from the previous lesson. In the previous lesson, we got an angle only in the first quadrant, so we had to then take that and reflect it to the second. But we don't have to worry about that in the law of cosines to find that missing angle. And that'll make a little bit more sense when we get into the example down below. Now, the law of cosines is written three different ways. Basically, it's a squared equals b squared plus c squared minus 2bc times the cosine of a. Now, the important thing that you have to understand here is if we have angle A, then side A goes over here by itself, all right? And then again, same thing, if we have side B, then we're taking the cosine of angle B, and if I have side C, then this is 2 times the other two sides, which in this case would be B times A, sorry. This would be A times B times the cosine of angle C. And then in front of this would just be A squared plus B squared. All right, so we always take, it kind of looks like Pythagorean theorem if you sort of eliminate this part over here. If you just look at this piece, it sort of looks like Pythagorean theorem. But because these angles are not guaranteed to be right angles, we have to tack on that last piece, the minus 2, and then it'd be the product of the two sides we actually have. And that's where we get into that case of having, two of the sides, for example, B and C. Well, that means that side A is over here, so angle A was here. So if we have these two sides and the included angle, we can use the law of cosines. So let's take a look at an example. Top of the next page, we're going to solve this triangle, and again, they say, what if we have the side angle side case? Well, to solve this triangle, it gives us side A, side C, and angle B to be 26 degrees. Now, as you guys know, when we start drawing our picture then, side B would be opposite of angle B, and that's the one that we don't have. And so in this case, again, it writes all the different formulas from the previous page. It really doesn't matter, again, because the labels of them will kind of dictate which formula you use, but it's really always the same thing. So in this case, it'd be the missing side b squared is going to be a squared plus c squared minus twice the product of the two sides we have, 7 and 12, times the cosine of b. All right, now again, make sure that your calculator is in degree mode before you start doing this calculation. All right, and this is really just kind of a plug and chug here. So a squared would be 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of angle B, which is 26 degrees. So plug everything in. So then b squared is going to be equal to, and I'll save you all the calculation, when we multiply all of this together, I would just type it into my calculator as one big old line. Again, making sure that you're in degree mode when you do this part. All right, don't miss any signs. Make sure you put your multiplications in between all of those, and don't forget the 2 as part of the formula. Okay. In any case, you end up getting that this is equal to approximately 42.0. There's certainly more after that. And so then we would say, all right, well, to solve for that, we would take the square root. Knowing that sides have to be positive, we would ignore the plus or minus. We'd simply take the plus, and the square root of 42 ends up being about 6.48. So that says our missing side is about 6.48. All right, from there, we would then go ahead and use the law of sines, because now we know all three sides and we only have one angle. All right, and so in our case, what I would strongly encourage is to find the smaller angle first. Again, the largest side here is 12, and so therefore the largest angle would be C. And this will save you a little bit of headache later on, because when you do the law of sines, you may end up with an angle. When you take the inverse sine, when we're solving this guy down here, we may end up finding that this angle right here, according to our calculation, is acute, but we know it has to be obtuse. And so my suggestion is to find the other acute angle first. All right? So we're going to use the law of sines to find that other small angle, in this case, which is angle A. Again, you could use this to find angle C, but it might cause you a little bit of headache. All right? So let's go ahead and say, all right, listen, the sine of A over side A is going to be equal to the sine of 26 over the missing side, which is 6.48. From there, we cross multiply by both sides, and we get 7 times the sine of 26 is equal to 6.48 times the sine of A. We would divide both sides by 6.48. That's just cross products, guys. And so I find out that the sine of A is equal to whatever 7 times the sine of 26 over 6.48 is. Don't forget your parenthesis here before you divide. Very important that that's there. You end up getting something in the neighborhood of 0.4735. All right? And then I would take the inverse sine of 0.4735, and I'd come out with angle A to be approximately 28.3 degrees. All right? So then, to find the third angle, we say, well, we know they add up to 180, so 180 minus the 26 we were given, minus the 28.3 that we just found, and altogether we find out that angle C is 125.7 degrees. All right? So angle C is about 125.7. All right, angle A happens to be about 28.3 degrees. And going back to our first side we found, side B is 6.48. All right, and so like I said, you can certainly at this point go over here and say the sine of C over 12 is equal to the sine of 26. Oops, I wrote 28. The sine of 26 over 6.48. All right, and then we could do cross products, but when you take the inverse sine here, you're going to end up finding that angle C comes out to an acute angle, and that's going to screw up some of your calculations. So like I said, that has to do with the fact that when you take the inverse sine, it's going to give you only an angle here in the first quadrant, and then we'd have to reflect that over here. So save yourself the headache, find the other acute angle first, to make your life a lot easier. Okay? All right, so checkpoint problem down below. Go ahead and give it a shot. Be right back with a solution for you guys. All right, first and foremost, we're going to draw a picture. Again, remember, I always put the angle I'm given down here in the lower left, so this is 77 degrees. And so side B is 15, and this one's 13. And so I'm going to draw something like that. So this is angle A, side A. Opposite the 13 would be angle C, and then this is B up here. All right, so for the law of cosines, then, we would say that A squared is equal to, and again, we're looking for A here, so that means I've got C squared and B squared. So this is going to be 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of 77 degrees. All right, and so when I do all that math there, I'm going to get A squared is equal to, and again, what I would do is I would just type this into my graphing calculator and just type that whole thing in there. Now I can't show that to you. Again, make sure you're in degree mode, but I'm going to go ahead and type in what I have here. So this should be 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of 77 degrees. And then again, the two sides we have are 13 and 15, and so this is going to give us what A squared is supposed to be. All right, so A squared is 306.27, you call it, and when I take the square root of both sides, I end up getting the square root of that becomes about 17. So this is about 17 and a half. All right, so that's my missing side A. Now from there, looking at all those angles or all those side lengths, they're all pretty close to each other. And so for that reason, I don't think you're going to get an obtuse angle in this triangle. But again, it makes sense to me to find angle C because that would be across from the smallest side. So I know that's going to be an acute angle. It's got to be less than 77 degrees. So I would take the sine of angle C over 13 is equal to the sine of 77 over 17.5. All all right, because that's my missing side. Again, I go 77 over 17.5, sine of c over 13. And now cross multiply. And so I get 17.5 times the sine of c is equal to 13 times the sine of 77. Divide both sides by 17.5. All right, and so I want 13 times the sine of 77 divided by 17.5. And again, that's going to be equal to the sine of c. And so sine c will be equal to whatever this mess is. And then I'm going to take the inverse sine of that to find angle c. So let's find out what the sine of c is first. Again, I can't leave the pen up there while I use the calculator. Sorry about that. All right, and so I want 13 times the sine of 77, 13 times the sine of 77, and then I'm going to divide that by my 17.5. And I'm just going to hit second answer to bring back my previous answer. And I get 0.7237. Whoops, I'll leave that open. Let's slide over here. And so the sine of c equals 0.72, we'll call it for right now. Now we're going to take the inverse sine of that to find out that angle c is inverse sine. And if you hit second answer, it brings back that previous answer. And I find out that's about a 46.4 degree angle. All right, so this is 46.4 degrees rounded to the nearest tenth. All right, so from there, let me slide my calculator out of here now. Now that I know that angle C is, let me pick a different pen color here, 46.4 degrees. Now I can say, well, 180 minus 77 minus 46.4, and that tells me that that final missing angle, angle B, is 56.6 degrees. So angle B, the measure of angle B is 56.6 degrees, the measure of angle C is 46.4 degrees, and the missing side A is 17.5 degrees. All right? Now a lot of work to do there, but again, understand you need all of that information if you're asked to solve the triangle. All right? Now let's take a look at the side-side-side case. In the side-side-side case, now you have all three of the sides, and my suggestion here, because I know when I take inverse cosine, it's going to give me an answer in the first or the second quadrant. All right? Again, inverse cosine gives me an answer in the first and second quadrant because, again, cosines are positive here and negative here. So when I'm working here, if I find that the cosine of this angle happens to be negative, that means I know my angle is between 90 and 180, meaning it's an obtuse angle. All right, now according to the picture, it sure looks like angle B is my biggest angle, but listen, I'm just going to put this 13 because that's the side that's the biggest. I'm going to assume, and I should, that it's opposite the largest angle. So when I set up my equation, I want to put B by itself. Again, the 13. So this becomes 13 squared equals A squared plus B squared minus 2 times A times B times the cosine, 2 times A times C times the cosine of B. Now again, I don't know what angle B is, all right? Sorry, this is a little hard to read in here. Let me clean that up a little bit. This is 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of B. Now, they just do some real quick math and go ahead and get you right to the cosine of B. I'm not comfortable just jumping right to that. So what I want to do instead is I want to kind of go over here in the margin. 13 squared is 169 is equal to 49 plus 81 minus, and then 2 times 7 times 9, that comes out to 63 times 2 is 126. 126 times the cosine of angle B. All right, we'll deal with that in just a few minutes here. Now, 49 and 81 comes out to, looks like 130. And so I'm going to minus 130 from this side and minus 130 from this side. I end up getting that 39 is equal to negative 126 times the cosine of B. Now, if I divide both sides by negative 126, I end up that the cosine of B is equal to whatever this is. Now, you'll notice that's a positive divided by a negative. Okay, that's no big deal because that's just going to end up being a negative number. So the cosine then ends up being negative 0.3095. All right, now, you're asking yourselves, well, how can that be negative? Remember, cosines are negative. That's the x value for every ordered pair. And so the x values are negative over here in the second quadrant. So what does that tell me? It tells me my angle is somewhere between 90 and 180 degrees. Another way to say that is angle B is simply an obtuse angle. So I take the inverse cosine of 0.3095, and it comes out to 108 degrees, approximately. All right, now that I know that this angle is 108 degrees, okay, I can't just go ahead and say, well, sorry, this is cosine, inverse cosine of negative 0.3095, and so this is 108 degrees. Sorry, wrong blank there. All right, so now I know one angle, okay, and I know all three of the sides. So to find one of the other angles, listen, I know these are both acute angles because I can only have one obtuse angle in a triangle. Otherwise, I would have more than 180 degrees. So from there, it doesn't matter which side I do next. I went ahead and found side A. So the sine of A over A is going to be equal to the sine of angle B, which is 108 degrees, over the length of side B, which is 13. Again, cross multiply, we end up getting A times the sine of 108 is equal to 13 times the sine of A. And so again, side A is 7. Okay, we already knew that. It's up here. All right. And so when I cross multiply and end up dividing, we end up getting 7 times the sine of 108 over 13. And so when I do that, I get something about like 0.5121, all right? And then I would simply take the inverse sine of 0.5121, and that tells me that the measure of angle A, sorry, I can't move the screen here, the measure of angle A ends up being approximately 30.8 degrees. All right, so now I know that side is 30.8 degrees. I know this angle is 108 degrees. I can use that to find the third angle in that triangle by doing 180 minus the 30 minus the 108. I end up getting something in the neighborhood of angle A, like we said before, is 30.8 degrees. Angle B is 48.9 degrees, and this is 56.8. Sorry, that's not correct. This is 108 degrees. This is 41.2 degrees. Sorry, I was looking ahead at the next question. So, all right. So for the next triangle, what you're going to find then is you should get, if you want to work this one out, I'm not going to take the time to work it out in the video to expedite some things here, but you should end up with A is 47.3 degrees, B is 48.9 degrees, and C is 56.8 degrees. So if you get those three angles, I want you to try to work that problem out, but those should be the angles that you come up with. All right. Again, it doesn't matter which one you work with first. Find one of them by using the law of cosines, and then work backwards to try to find any of the other two using the law of sines. All right. So those are the answers you should be getting. Go ahead and try that one on your own, maybe even now or after the video sometime. Give it a shot, and we'll talk about questions tomorrow. What I really want to get to is this last piece called Heron's area formula. And Heron's area formula is kind of interesting. All right. Heron's area formula says this. It says the area of a triangle with side lengths A, B, and C is equal to the square root of S times S minus A times S minus B times S minus C. Now, in the previous lesson, I gave you an area formula that you could use if you had one of the angles. All right. In Heron's area formula, it assumes that you have all three sides of the triangle. So if you have all three sides of the triangle, you can use this formula, which is the square root of S times S minus A times S minus B times S minus C. We might be asking, well, wait a minute, what's S? Well, S is basically just half of the sum of all three of the side lengths. All right? So add all of your side lengths together and take half of that. All right? It's called the semi-perimeter. We call that the semi-perimeter or the half perimeter. Well, think about that. The perimeter of the triangle would be A plus B plus C, and so the half perimeter would be half of that. All right? So we take the half perimeter, which is S, and we do S times S minus A, S minus B, S minus C. All right? So, multi-step problem here down below. There's a story problem. Pretty straightforward now, again, now that you have Heron's area formula. So we first find the half perimeter, or the semi-perimeter. It'd be 1/2 of 92 plus 64 plus 130. All right? And so once we do that, we end up getting that the semi-perimeter is 143 feet. Okay? Keep in mind this is in feet. So when we do area, my answer had better be in square feet. So then Heron's area formula says it's the square root of 143 times 143 minus 92, 143 minus 64, 143 minus 130. And so I would, one of two things, I can just type that all into my calculator as it exists. I can find each term individually. It totally does not matter. Make sure you multiply them all together and take the square root. This ends up being about 2,737 square feet. All right, there's a checkpoint problem at the bottom of the page, a couple of Heron's area formula problems. The answers for those two questions, I'll give you the answers for them, and I want you guys to go ahead and do the work for them, and we'll check on those tomorrow. For this one, you should get something about 13.6, and there are no units given here, so we're just going to call it square units. Same thing with this one, 2,170 square units. Again, the answers for those are given. I want you to try to work those two problems out and see if you get what I got there. Don't forget that you have to calculate the semi-perimeter first, which is half of the lengths of all the sides added together, okay? Because you need that for Heron's area formula. All right, so that concludes lesson 13.6 on the law of cosines.